All right, Algebra 2, here we go, guys. We are starting section 9, last section of chapter 5. Okay, we got quite a few example problems, so pay close attention. We're getting into operations with complex numbers, so yes, we are still dealing with imaginary, lowercase I, doing a teeny bit of graphing, but not a lot. All right, and it's pretty simple. No more third dimension graphing or anything like that. Okay, so let's just follow along with these notes right here. You guys can see on the screen. Go ahead and copy that down. Make sure you understand that the imaginary axis is your vertical one. The real axis is your horizontal one. As you can see, I give you the page number there, so take a look at 382 so you can follow along in the textbook. You're going to want to copy down that chart. And again, I understand if you guys don't copy these down, that's your call. But this is one of those things where I know it's going to come back and be very helpful to have that on the test. So if I say, hey, copy down this chart, it might be helpful to have it for the test. At the bare minimum, you want to really understand and know how to use that chart for your homework, for future assignments, and of course for the test. All right, so you can copy all this stuff down right here, but I will tell you this, that 384 chart where it's all the powers of I, that is very helpful. All right, you might want that chart right there. So that's the powers of I on page 384. Okay, here we go. Let's do some example problems. Let's jump into this. Okay, so we're going to graph on the complex plane. There you see it. Everything's going to be color coordinated here. So for A, we're going to do it in blue, B is green, C is yellow. So for 2I, all we need to do for this, you can see the imaginary axis is the vertical one. We don't have any real numbers. So all we're going to do is go up 2, put it right there. That's easy enough. That's where A goes. All right. Now, part B, we have -2, then -I. All right. So -2 would mean we're going to go to the left twice, because that's the real axis, left twice. Then -I means we go down one time. So we go left twice, then we go down once. We're going to be right there. That's where B is. Okay. And the last one we have here, +3 plus 2I. So a +3 means real axis, 3 times to the right, twice up. 1, 2, 3, twice up. We are right there for our C value. All right, simple enough, easy. If you need to see that again, rewind it, go back through. Okay, all right. Let's move down. Here we go. Next part, find the absolute value, but we're using imaginary numbers. Okay, you see that note right there in green? That's the equation we use. Okay, so we're going to rewrite this absolute value as a square root 1 squared plus that plus sign right there. That's given in the equation. So we put a plus sign, and in parentheses, we're going to have a -2 squared. Notice you don't square I, so leave the I out. So what is 1 squared? 1. Plus, what's -2 squared? 4, all still under the radical. This just works out to be radical 5. All right, that's what we get for that one there. Again, make sure you see that plus sign right up here. That's in the equation. You have to do that plus sign. That negative sign that's right here, that came from that right there. Okay, and anytime you square a negative, though, it's going to go back to being a positive. So that's kind of helpful. All right, next one here. Again, we don't square I. So if we are going to take 0, because we don't have anything up front, squared, plus 23 squared, 0 squared, that goes away. And then if you can imagine here, you have basically just the square root of 23 squared. Well, these guys cross each other out. Squared and square root cross each other out, leaving just 23. So that's all you got for that. There's all the arithmetic steps to get that one there. Okay. All right, let's move into the next one. We have adding and subtracting. Don't forget the format. All right, this format right here. A, the real number, plus BI, the imaginary number. All right, so for starters, if we have a lowercase I, like we have right here and right here, we know that we already have some like terms. I don't see any other real numbers except for 3. So now what we need to do is you have this negative sign. That actually has to be distributed into the parentheses. So let's rewrite this as 2i now minus 3 minus 5i. Okay, don't forget that format right here. So that negative 3 is going to get put out in front. Then we have like terms, all right, because that lowercase I links these guys together. Now you have 2 minus 5, giving you a negative 3i. All right, so don't forget, if you have like terms, that would be imaginary numbers, treat their coefficients as like terms. Then the real numbers, if you had 2 of those, treat those guys, again, as numbers you can combine together. Okay, let's move on to the next one here. All right, if you have a plus sign in the middle, we kind of like these because then none of the signs really need to change. So you can just write this as one fluid equation. So we can say this is 4 plus 3i plus 4 minus 3i. All right, so none of the signs change. The parentheses really didn't need to be there because that plus sign in the middle. So the 4 and the 4, that's going to make 8. Then you have a positive 3i minus 3i. So these guys will cross each other out. That's all you have. It's just 8. So the imaginary numbers cross each other out, leaving you just with the real positive number, 8. All right, let's move down. Now we are multiplying. So basically we are doing FOIL. Okay, so that's going to be the first, outer, inner, last. So let's follow the whole thing we have here. We have 4 times 6, giving us 24. Then we have 4 times a negative I, giving us negative 4i. Okay, imagine that there's a 1 in front of it. All right, think of it like that. So there's a coefficient there that we're multiplying that 4 by. Okay, now we have negative 4i times 6. So that's going to give us a negative 24i. And now here comes the fun part. All right. Now we are multiplying a negative 4 by a negative 1. Okay. So that is giving us a positive 4. But in parentheses right next to it, I multiplied by I equals negative 1. All right. If you want to see what I'm talking about here, flip to that chart on page 384. That's the whole chart. It gives you everything from I to the power of 1 all the way to I to the power of 12. It's super helpful, okay? But this is really important. I times I equals negative 1. And basically think of that as I squared, all right, equals negative 1. So that's going in there. So really, here's what we're dealing with. We have 24 minus 4i minus 24i. These guys right here actually make minus 4. Okay? So what we're dealing with now, let's use another color, we have 24 minus 4 giving us 20. Then we have a negative 4i going with a negative 24i, giving us negative 28i. That would be the final answer there. And don't forget the format. It goes real number, then imaginary number, which is what we have here. 20 is real, negative 28i imaginary. All right, let's move into the next one. Again, distribute. 3 goes to 3, giving us 9. 3 goes to negative 2i, giving us negative 6i. All right, now we have the other side. 2i goes to 3, giving us a positive 6i. And then 2i to a negative 2i. So 2 times negative 2 gives us negative 4. Don't forget I times I. We're going to have a negative 1 to multiply that by. So this is now going to be 9 minus 6i plus 6i plus 4. here's one thing that we like. These guys, negative 6i, positive 6i, they cross each other out. All right, they're perfect opposites, which is great. So cross those guys out. Then all you're dealing with here is just 9 plus 4, so 13. That's it. That's the final answer that we get on that one because the imaginary numbers cross themselves out. All right. Now, we are moving into using that chart, the very helpful chart at the bottom of page 384. So let's take a look at what we have. If we can look at that chart and see that I to the power of 7 equals negative I, then really what we're dealing with here is treat this as negative 1I multiplied by a half, because that half right there. And what are we looking at? We're just looking at a negative 1/2 I. That is how helpful that chart is. So you don't have to worry about breaking out I times I times I 7 times. Use that chart. Memorize that chart if you really want to be ahead of the game, but at least write that chart down. Have that for your reference. Okay, now I to the power 42, yeah, that is not in the chart, but we can break this down. Okay, so here's how we break this down. We're going to take I squared and bring that to the power of 21. All right, now here's what is very helpful about that. I don't want you to think, oh, well, great, they don't have I to the power of 21 in the chart. Doesn't matter. Who cares about that? But they do have I squared in the chart. So this is the same thing as saying negative 1, because that is what I squared is, to the power of 21. Now you need to kind of go back and start to think about understanding even number powers and odd number powers. All even number powers will create a positive number. All odd number powers will keep the sign the way it is. So what you're looking at is a negative 1 to the power of 21. 21 is an odd number. So the answer to this, for starters, 1 times 1, it's always going to be a 1. But is it a positive or is it a negative 1? It's going to stay a negative 1 because of the rule that I just said. Odd number powers. 21 is odd, so the power of 21 keeps the sign the way it is. It was a negative 1, so it stays a negative 1. So that's how you do that big I to the power of 42. All right, guys, last example problem. Stay with me. Stay with me. Here we go. So what we're doing here is we are dealing with these complex conjugates. You remember we were doing that in a previous section, okay? So we got to write the conjugate and multiply that by the top and bottom. What's the conjugate? Well, it's the perfect little opposite of what was given. So we were given 2 minus I. Well, the conjugate is going to be 2 plus I. Why do we use the conjugate? So that we get the imaginary number out of the denominator, because you can't keep an imaginary number in the denominator. Watch these videos. They're important. All right, here we go. So multiply the top by the same thing. Now distribute exactly like we've already done with multiplying. So we're going to do 2 times 2, giving us 4. 2 times I plus 2I. Negative I times 2, it's going to be a negative 2I. And a negative I times I. So that's going to now basically give us, let's see, it's going to give us a positive 1. That's right. Okay, now what we like about this is that these middle terms should always be crossing out, leaving just real regular numbers. Okay, so why is it a plus 1 instead of a negative 1? Because you had a negative I mixed with a positive I. So that's why the sign is now changing. Remember before I said I times I is negative 1? Well, that's when they were both positives. What if we change the sign on one of them? Well, now it flips it to be a positive 1. So 4 and 1 are going to make 5. So our denominator now is just 5. But now we need to simplify the numerator. So let's do that. 3 times 2 gives us 6. 3 times I plus 3I. Negative I and 2 give us a negative 2I. And now again, opposite signs. Negative I and a positive I giving us a positive 1. So let's simplify all of this. So don't forget, we still have a 5 in the denominator. 3 minus 2, that's just going to give us I. 6 plus 1 is going to give us 7. So we now have a 7 plus I over 5. That's it. That's our final answer for that one right there. All right, guys, as promised, last example problem. There was plenty of example problems in here. So pay close attention, watch it, rewatch it. It's the last section. Finish strong. Keep working hard. You guys got this. See you in the next one.